ArcGIS and the HAZIS software program that was developed by FEMA, as well as something called the Valley Floor Mapper. Now they can be used at different times to get different data. So the first thing we need to do is develop a flood depth grid to figure out what buildings are flooded, and then we need to figure out where the buildings are, and then we're going to use HAZIS to determine the flood damage. Now in order to run HAZIS, you have to have ARC installed on your computer because it's a sort of a subroutine of ArcGIS. Alright, so to develop the flood grid, there's three ways of doing it. We can either do it in Switch.
It's okay. I'll keep up with you. Go ahead.
Okay. In order to do that, we need, I forgot where it was. All right, we can do it three different ways. We can do it in HAZIS and use their default data. We can use the FEMA National Flood Layer to get specific data, to get better data, and we can use the Valley Floor Mapper. And so in order to do that, we need a bunch of data input. So we can get the National Flood Hazard Layer from the FEMA website, from the mapping center. You have to download HAZIS onto your computer, obviously, and we need some elevation data. And we can get that from the National Elevation Data, which is NED. It's going to be a lot of initials thrown around, so I'm hoping to capture them all. We can just get from the National Map website, and there's a link there as well. Or if that's 30-meter pixel data. If you want to get more specific, you can use any kind of elevation data as long as it covers your site. So you can use, Massachusetts has LiDAR data. NOAA has done the whole coast, so you can really use whatever elevation data. So to download the flood hazard layer, it's from the FEMA Map Center, and you have to download it by state, county, and community. Even if you're doing a county-wide analysis, you still have to download it by community. But once you get to the community level, you can pick any community, and it'll just give you the county and the state level all at the same time. So when you input all the search criteria, it gives you, some choices of what you want to download, and we want to download it by county. I was just doing it for Plymouth County, so that's just the one I picked. And it just lets you download all the data. So what it downloads is a bunch of shape files that are going to go into ArcGIS, and this is what your download folder will look like once it downloads. It's all these different files that go along with that. And when I load them all into ArcGIS, these are all the shape files loaded in. But we don't need them all. There's a lot of information in here that we don't need. There's some index files. There's some other, coastal areas or whatever. So the ones that we really are going to need to use are the base flood layer cross-section, which is called SBFE, the stream centerline data, which is the S water line, and the flood hazard layer. And those are the layers I input, and then that turns out to look more like this. And this is just a close-up of some streams in Plymouth County. If I open the attribute table for the base flow cross-section, we can see that there's an attribute called elevation, and that's the 100-year flood elevation. Now this example I'm going to run through really quickly right now is just for the 100-year flood elevation, and there are ways of doing the 10, the 500, the 50-year as well, all from this data. So I'm just doing the 100-year. So this is the 100-year flood elevation. So what we want to do is we want to translate this elevation into a flood depth. So I'm going to put points, and again using ArcGIS, I'm going to put points at the ends of each of the cross-section lines. And there's a picture of all the cross-sections in the red with the points on the end of them. And I'm going to use an inverse distance weighting function from the points, because we know the elevations of each of those points, to create a flood depth grid. So this is basically a grid of the flood depth only around the cross-section points. So what I need to do now from that is figure out only around the streams what's been flooded. So I'm going to subtract the ground surface elevation, which we got from the DEM, the digital elevation model, using LiDAR from the National Elevation Data Set. And if I have a depth of flooding and a surface depth, when I subtract them from each other, the negative values is where the ground surface is above the flooded elevation, and the negative values is where there's flooded areas. So I want to sort of get rid of the negative values. And again, it just functions in GIS that's going to let me do that. I'm going to eliminate all the negative values. And what I'm left with is a polygon file of just the flooded area. So that's the extent of the 100-year flood. And I'm going to use that data, that polygon, to clip out from the flood depth grid, from this blue grid, to get actually the flood depth grid for the 100-year flood. And that's what it's going to look like. we're going to use that as part of our input into hazards. Valley Floor Mapper is another tool to get the same information, although it doesn't require the FEMA layer and it doesn't require ArcGIS. It's a tool that was developed by some place called the Macroecological Riverine Synthesis, and it's part of a bigger tool called the Resonate tool. And it uses a GIS interface and it uses a MATLAB interface. I don't exactly know what it's doing outside, but you need a flood direction grid and a flow accumulation grid, and both of those are available from NHD Plus website that you can just download. You can just download those two data sets. You don't need ArcGIS to do that. You need a digital elevation model, a DEM, and you also need to specify a depth to the flood. So you can specify a constant value over the entire stream section, so say for 10 feet of flooding for the entire stream, or if you have specific flood depth per stream segment, you can input that as a table. And this is what it looks like. So there's actually 3 tools it runs through. This is the first tool that the program Valley Floor Mapper uses for the next step, and it's just generating some files that it needs. So basically it's taking all the streams, it burns the streams in, and takes the streams and generates a segment information file and gives the segments each an ID. So you input the flow direction file, the flow accumulation file, and it gives you these 2 files, neither of which you would ever actually look at for anything unless you want to generate, like look at the IDs of certain streams. So from those, you're going to take those 2 outputs from step 1 and put them into step 2, along with the digital elevation model, the DEM, and the flood depth, the depth to flood, and whatever that is, whether you want to specify it as a single value, say it's like 20 feet or something. And you can also specify the steps that goes at. So if you say, I want 20 feet to flood, but I want outputs every 5 feet, you can also specify that in that flood depth step size. And it processes through each of those and gives you an output file. Now, and what that's going to give you is an output that we're going to put into step 3 to develop the output depth grid. And I'm assuming it's going to work. It is working at home, so I can see it's processing through the files. And so, but it is a time consensus tool so far. And then it gives you the depth grid for each of those steps. So that you can use that tool. Or you can use HAZUS, the program that FEMA developed, and you can just use their default grid. So you can just download the DEM straight from the NEC. There's a download tool. You click on the tool, you put on the area, and it downloads the exact DEM you need. It will create a stream network for you. Unfortunately, you can't input your own stream network. It has to do it for you. So it runs its own hydrology. And you can specify what return intervals you want, so 10, 50, 100, 500, and it runs all the hydraulic analysis for you, figures out all the depth grids and everything. It uses USGS regression equations to do that, so if you have better regressions or want to do it in a more accurate way, then that's what it is, it's just the default data. So once you get the depth grid, the next step is to develop the building inventory and figure out which buildings within those grids are going to be flooded. Now, HAZUS assumes that HAZUS maps on a census block or census tract level, and it assumes, it has a newer version now, but it assumes that all the buildings are evenly distributed throughout the census tract. And right, it has HAZUS 3.1 has removed the undeveloped areas in those areas, so it won't let water, wetlands, forests, and somehow sort of lumps all the other area into the buildings that it knows are there from the census data. So it's a little bit more accurate than the old version of HAZUS, but it's still not super exact because it just doesn't assume in the remaining land that's left after taking out the land that you can't develop that the buildings are uniformly distributed. It doesn't know exactly where they are. So the best way to do that is obviously to get your own building inventory for whatever area you're looking at. So in Massachusetts, there's actually a building footprint shape file that's on the Massachusetts GIS website. And there's also a database layer in the Mass Oliver website that actually gives you database information from the assessment. So it gives you price of the house, how many floors it has, what the building use is, things like that are necessary for houses to process. So once you have a building footprint layer, we actually need, HAZUS uses point values for the building. So we have to actually just generate one point at the center of the building. And we also want to take out all the extra buildings or the outbuildings because they're not really going to be included in the flood damage curve. We only want to know what's going to happen with the main buildings on the property. So what I did was, when I missed the first time, was assume that things smaller than 600 square feet were outbuildings, garages, whatever. You can look look at aerial photos to delete those buildings, and however way you want to do that. There's lots of different methods. So you have one building left per site, and then HAZUS needs some specific attributes for each building to process its damage curve. So it needs to know actually where the buildings are, so it needs the latitude, longitude of the center of each building. It needs the occupancy type of the building. It needs the first floor height above the ground. It needs the number of stories, and it needs the building value. And it's very specific as to how it has to go into HAZUS. So the HAZUS user's manual gives you step-by-step instructions on how to input it into ARC or into Access, and the actual formatting of the data, how it has to go in, and the field sizes and all that. So if you needed more information on how to do that. And once we're done with that, we have the buildings, we know how much they're worth, and we know where they are, and then we have the flood desk grids, so we're now going to combine those into HAZUS. So the first thing HAZUS needs us to do is create a scenario, and you can just call it whatever you want, but you just have to create it. And then once you create the scenario, you just say you want to run the analysis, and you have to input the desk grid, and you have to input the facilities, and you can just click on whatever things you wanted to analyze. I just clicked on everything, so it's running an analysis on everything in the flood area with my user-defined buildings, and then I'm going to look at the results. And HAZUS gives us a bunch of different ways to run the results. We can view them in a tabular method, and this is really what we're going to want because this is the table we'll actually export to get the cost damage function. And you can do it by general building stock, commercial, residential, and lots of different things. It also lets you figure out how many vehicles might be damaged, how many agricultural products, how many casualties, how much debris in terms of tons it generates. But we only care about the building cost. You can do it graphically. You can do it as a thematic map. And you can do it as a crystal report or just as a printed PDF, nice report of everything summarized. So here's an example of Plymouth County when I ran through the whole thing, and I did 4 years. I did a 10-year flood, a 50-year flood, 100 and 500-year flood. And you can see, it's sort of hard to see, but you can see the buildings by type pop up in different colors. The green dots are residential, the blue dots are commercial properties, and the red dots are industrial properties that were damaged within the flood grid. And you can use the HAZUS output, and you can generate a table like this. So you can have each of the three kinds of buildings, or you can have a combined damage curve. And then so you're going to take that damage curve along with those return periods and put them back into the flood module that Vicki had up in that table on the first page of the flood module. That's it for me. Any questions? It's a lot of GIS stuff, so if you don't know GIS, then you have to, push it off to the person in your office who does. But hopefully we give you some idea. And I think that the manual that we sent out gives much more step-by-step instructions on how to create those grids, exactly what steps in GIS to do it. So if you have the GIS program, it's fairly straightforward. Okay. Sure.
So, the creating flood desk grid, you mentioned that you have a two segments and you
Yes.
give values in segments. Where do you get that information? Like point?
That's from the FEMA flood hazard layer. Gives you the elevation. So I zoom back. So that's very. It actually gives you as one of the this one, right? The elevation that's given. That's in the attribute table when you download it from FEMA.
The one for
This one. So for each of those red lines, this attribute here, the elevation, is the elevation at each of these red lines. The elevation is the elevation at each of those red lines. So then I just use the command that says add points to the end of the line.